Hi, we're going to take a look at some circle similarity and scale factor related to circles. We're going to be able to prove circles are similar using transformations, and we're going to be able to describe and apply how scale factor affects circumference and area. So a few things to freshen up on. A circle's size, how big or small it is, depends only on its radius. A similarity transformation is where you could have one or more rigid transformations. Rigid means that it's a transformation that preserves congruence, meaning all the sides and all the angles are congruent for the preimage and the image, followed by a dilation. So the key is the dilation is the one that specifically denotes it being a similarity transformation. So we can prove all circles are similar using a translation, which is just moving the graph left or right, up or down, just sliding it somewhere else, and also a dilation. You got to change its size using some sort of scale factor. So another few things that we're going to add to the margin is your scale factor. My abbreviation SF means scale factor. It's an enlargement when the scale factor is greater than 1, and it's a reduction when your scale factor is between 0 and 1. So scale factor is typically a positive value, but if you have like a fraction like 1/2, 3/4, those are examples of reduction. But also be mindful that there are fractions that are greater than 1, such as 5/2. That would be an enlargement. So now let's go ahead and take a look at how we're going to prove circles are similar. So in our example, we're going to show how circle X is similar to circle Y. So we're going to have to utilize our translations and dilations to kind of map circle X onto circle Y. So first step, we're going to translate circle X 6 units to the left. Next, we're then going to translate circle X down 7 units. So I did a dotted circle in blue to show step number 1 when we move it to the left. And then I'll use the green to show you step number 2. So blue circle represents the first step. The green dotted circle represents the second step. And then the third step is to dilate circle X by a scale factor of 1/2. So do you notice how the green dotted circle is larger than circle Y? That means I have to do a reduction, so something less than my original. So since X is bigger than Y, then I have to do a reduction, which is a scale factor between 0 and 1. So the radius of circle X is 6. The radius of circle Y is 3. So how do you get from 6 to 3? Multiply by 1/2 or divide by 2. That's how I pick the scale factor 1 over 2. So just a quick refresher, scale factor is derived from taking the image length over the pre-image. So that's why it is 3 over 6, which reduces to 1/2.